Dear students, today I will give an introduction to soil mechanics with particular reference to genesis of soils and composition of soils. Soil mechanics is a branch of soil physics and applied mechanics that describes the behavior of soils. It differs from fluid mechanics and solid mechanics in the sense that soil consists of a heterogeneous mixture of fluids, usually air and water, and particles, usually clay, silt, sand and gravel. But soil also may contain organic solids and other matter. Along with rock mechanics, soil mechanics provides the theoretical basis for analysis in geotechnical engineering, a subdiscipline of civil engineering, and engineering geology, a subdiscipline of geology. Soil mechanics is used to analyze the deformations and flow of fluids within natural and man-made structures that are supported on or made of soil, or structures that are buried in soils. Example applications are building and bridge foundations, retaining walls, dams, and buried pipeline systems. Principles of soil mechanics are also used in related disciplines such as engineering geology, geophysical engineering, coastal engineering, agricultural engineering, hydrology, and soil physics. Then we will discuss the genesis of soils. The primary mechanism of soil creation is the weathering of rock. All rock types, that is igneous rock, metamorphic rock, and the sedimentary rock, may be broken down into small particles to create soil. Weathering mechanisms are physical weathering, chemical weathering, and biological weathering. Human activities such as excavation, blasting, and waste disposal may also create soil. Over geologic time, deeply buried soils may be altered by pressure and temperature to become metamorphic or sedimentary rock, and if melted and solidified again, they would complete the geologic cycle by becoming igneous rock. Physical weathering includes temperature effects, freeze and thaw of water in cracks, rain, wind, impact, and other mechanisms. Chemical weathering includes dissolution of matter composing a rock and precipitation in the form of another mineral. Clay minerals, for example, can be formed by weathering of feldspar, which is the most common mineral present in igneous rock. The most common mineral constituent of silt and sand is quartz, also called silica, which has the chemical name silicon dioxide. The reason that feldspar is most common in rocks but silica is more prevalent in soils is the feldspar is much more soluble than silica. Silt, sand and gravel are basically little pieces of broken rocks. According to the Unified Soil Classification System, that is USCS system, silt particles sizes are in the range of 0.002 mm to 0.075 mm, and sand particles have sizes in the range of 0.075 mm to 4.75 mm. Gravel particles are broken pieces of rock in sizes ranges from 4.75 mm to 100 mm. Particles larger than gravel are called cobbles and boulders. Then the transport. Example, soil horizons, topsoil and colluvium. Then mature residual soil, young residual soil, and weathered rock. Soil deposits are affected by the mechanism of transport and deposition of their location. Soils that are not transported are called residue soils. They exist at the same location as the rock from which they are generated. Decomposed granite is a common example of a residual soil. The common mechanisms of transport are the actions of gravity, ice, water, and wind. Wind-blown soils include dune sands and loess. Water carries particles of different size depending on the speed of the water. The soils transported by the water are graded according to their size. Silt and clay may settle out in a lake, and gravel and sand collect at the bottom of a river bed. Wind-blown soils deposits, that is aeolian soils, also tend to be sorted according to their grain size. Erosion at the base of glaciers is powerful enough to pick up large rocks and boulders, as well as soils. Soils dropped by melting ice can be a well-graded mixture of widely varying particle sizes. Gravity on its own may also carry particles down from the top of a mountain to make a pile of soil and boulders at the base. Soil deposits transported by gravity are called colluvium. The mechanism of transport also has a major effect on the particle shape. For example, low velocity grinding in a river bed will produce rounded particles. Freshly fractured colluvium particles often have a very angular shape.